In the previous session, we have seen the introduction and structure of salbutamol. In this session, I'll give you the detailed explanation about the salbutamol. The first method of preparation of salbutamol from orthohydroxybenzyl alcohol and alpha chloroacetyl chloride. In this first method of preparation of salbutamol, the mechanism involves in a three steps. In the first step of mechanism, the orthohydroxybenzyl alcohol reacts with the chloroacetyl chloride, which gives intermediate 1. Why we are calling it as orthohydroxybenzyl alcohol? In this structure, both OH group and CH2OH group connected at a adjacent position. They are not separated by any other carbon atoms. Both are ortho to each other. That is the reason we are calling it as orthohydroxybenzyl alcohol. When it is on treatment with a chloroacetyl chloride, in chloroacetyl chloride undergoes some polarization which gives two ions. Those are Cl minus ion and CO plus CH2Cl ion. Thus liberated electrophile, that is COCH2Cl plus ion, may attack at a para position to the OH group. Here the OH group is considered as an electron releasing group. So this group invites or allows the incoming electrophile at a para position. That is the reason the COCH2 electrophile attacking takes place at a para position, which is para to the OH group. In the first step of mechanism, what happens here? Electrophilic substitution happens. In the second step of mechanism, why we are calling it as a electrophilic substitution? Whatever the hydrogen attached the para position of the benzene is released as a H plus ion. That H plus is substituted by the incoming COCH2 plus ion. That is the reason the first step is the electrophilic substitution reaction. In the second step of the reaction, the tertiary butyl amine reacts with the intermediate 1. There is liberation of hydrogen from the tertiary butyl amine and chlorine from the intermediate 1 structure. They are released as a hydrochloric acid. There is a making of the bond. There is a connection between the carbon atom of the intermediate 1 and nitrogen atom of the tertiary butyl amine takes place to form a intermediate 2. In this structure, the structure undergo MPV reduction. The full form of MPV is Merwin-Ponroff-Verley reduction. We should reduce the keto functional group, especially into the alcoholic group, by adding 2 hydrogens to the carbon and oxygen atom of the CO functional group. CO, here the CO functional group gets reduced into the alcoholic functional group by adding 2 hydrogen atoms. Finally, we are getting salbutamol structure. All these are the steps involved in this mechanism. The first step undergoes electrophilic substitution. Second step, there is a liberation of hydrochloric acid when you are reacting the intermediate 1 with the tertiary butylamine. Finally, in the final step, undergo MPV reduction, which gives salbutamol structure. It is about the first method of preparation of salbutamol. The second method is synthesis of salbutamol from 2-hydroxybenzaldehyde. Let us look into the mechanism of second method of preparation of salbutamol by using 2-hydroxybenzaldehyde. In the structure of 2-hydroxybenzaldehyde, CHO functional group connected at the first position of the benzene. The second position was occupied with the OH group. Thus, the name of the compound is 2-hydroxybenzaldehyde. It is the IUPAC name according to the IUPAC nomenclature. The common name of this particular compound is salicylaldehyde. Suppose if you take COOH functional group instead of CHO functional group, then the name of the compound is salicylic acid. You just don't bother about the salicylic acid. Here, 2-hydroxybenzaldehyde or salicylaldehyde is taken as a starting material. It is on halogen acetylation in presence of the aluminum trichloride catalyst gives intermediate 1 structure. In the first step of mechanism, what happens is there is an attacking of electrophile takes place at the para position of the 2-hydroxybenzaldehyde. Here the OH group is considered as a electron releasing group, so that it invites the incoming electrophile, that is C double bond O CH2X plus ion, may attacking at a para position to make the structure intermediate 1. Further, it is on treatment with tertiary butyl amine, which gives imine formation in the second step of mechanism. there is a elimination of two hydrogen atoms from the tertiary butylamide and oxygen atom from the intermediate one. Both are released as a water molecules to give imine formation in the second step of mechanism. Later, it undergoes nucleophilic substitution in the third step of mechanism when it is on reacted with the tertiary butylamine. In the nucleophilic substitution reaction, the X is replaced by the amine group to make the intermediate structure 2. In the next step of mechanism, there is undergoing some hydrolysis process to make the intermediate 2 structure. Further, it is on reduction with a homogeneous catalyst like palladium. Here, by the addition of the two hydrogen atoms, the carbon atom and oxygen atom of the keto functional group gets reduced into the alcoholic functional group. Finally, we are getting salbutamol structure. All these are the steps involved in the mechanism of the second method of preparation of salbutamol. In the first step of mechanism, electrophilic substitution reaction takes place. In the second step of mechanism, there is a formation of imine. In the third step of mechanism, undergoes nucleophilic substitution reaction. Further, it is on imine hydrolysis and followed by reduction gives finally salbutamol. Next, we will discuss about the medical benefits of the salbutamol. Salbutamol is used to relieve symptoms of asthma and chronic obstructive pulmonary disease such as coughing, wheezing, feeling breathless. It works by relaxing the muscles of airways into the lungs, which makes it easier to breathe. You can look at the picture. Emphysema. Emphysema disease is one of the diseases that comprises COPD. It is one of the most respiratory illness caused by the smoking. Not only the reason smoking, other causes also. Emphysema develops over time and involves the gradual damage of the lung tissues, specifically the destruction of the alveoli. Those are tiny air sacs. Gradually, this damage causes the air sacs to rupture and create one big air pocket instead of many smaller ones. You can see the rupturing of the many smaller air sacs will be turned into the big single air sac. It looks like a big air pocket. It leads to lung surface area, traps air in the damaged tissues and prevents oxygen from moving through the bloodstream. Additionally, this blockage causes the lungs to slowly overfill and makes breathing increasingly more difficult. This can be cured, this emphysema can be cured by using salbutamol drug. Moving to the next slide, side effects of the salbutamol are trembling, nausea, vomiting, headache, irregular heartbeat, palpitations, tachycardia, and the last one is hyperglycemia. What is trembling? Trembling means shaking typically as a result of anxiety, excitement, or some nervousness. Nausea, vomiting, headache, irregular heartbeat are the common side effects of the salbutamol. The next one is the palpitations. Palpitations, and it is a noticeably some rapid, strong, or irregular heartbeat due to agitation, exhaustion, or illness. Although heart palpitations can be usually harmless. The next side effect is tachycardia, means that your heart is beating much faster than normal. Usually it's more than 100 beats per minute. The last side effect of salbutamol is hyperglycemia. It is a condition in which an excess of glucose in the bloodstream. Often it is associated with the diabetes mellitus. All these are considered as side effects of the salbutamol. You can look at the pictures of salbutamol. Those are palpitations, irregular heartbeat, shivering, headache, and you can also observe the skin allergies. The next slide is drug-drug interaction. What is a drug-drug interaction? Drug-drug interaction is a reaction between two drugs or between a drug and a food or between a drug and beverage or between a drug and supplement. Taking a drug while having certain medical condition can also cause a drug-drug interaction. For example, taking a nasal decongestant may cause an unwanted reaction, that is, it increasing the blood pressure. Here, the salbutamol can react with the certain types of other drugs. The given examples are here. Here, the corticosteroids for asthma, such as beclomethasone, dipropionate, diuretics like furosemide, etanolol or propanolol. These are the blood pressure medications. And the next one is the drug which is used to regulate abnormal heart rhythms like digoxin, certain antidepressants such as moclobemide, phenelzine, amitriptyline, clomipramide or imipramine. Breathing aid tablets recommended for asthma such as theophylline and aminophylline. All these are the drugs. We can interact these drugs with the salbutamol. Breastfeeding and pregnant women should be avoided to take this salbutamol. Next, we will look into the doses of the salbutamol. Salbutamol can be available in either tablet or syrup or inhalers, or you can take through intravenous injections. There are two types of inhalers. We can see that is MDI full form is metered dose inhaler and DPI is dry powder inhalers. Adults can take 2 to 4 mg per day. Children can take 1 to 2 mg per day. This is the information about the doses of the salbutamol. Here there are some pictures of the salbutamol can be available in syrups, tablets, inhalers. It is the information regarding the salbutamol. Thank you. All the images in this video have been taken from Google Chrome. Thank you.